Yes. LDA is done with
Binary.
two classes, right?
Yes.
We did with multi-classes, right? But if you do it with two classes versus, how you will do it?
Okay, you can do it like this. It will separate.
Now what we're talking here, is it one versus two, or one versus all, or three directly? How you do it? But actually using binary only.
One versus all.
One versus all.
One versus all?
Yes.
But do you think it's better to do it versus one versus two or versus three binary? Okay, if you do one versus all, right? You get something like this, right?
Yes.
If we do red versus others, will be something here, right? So here what I did, only two, one versus two, one versus three. This is separation, right? Let's do the next one. One versus two. So here we're using the LDA, right? Two versus three. There is small overlapping here, see here? Here's this region here, the triangle here. And here you can classify. So if it's small area, so it is really rare to have the data in this small region.
What if we draw line from little bit up?
Oh, you can, yeah, you can.
Professor,
There will be no.
Yeah, you can.
if we're doing LDA, shouldn't we separate, for example, W1 and the others is?
But you have your classes, training data set, so you can separate two by two.
Yeah, I know, but if we're doing LDA, shouldn't we have a class like this? Like this? This is if I draw it like this.
But you are talking about one versus one or one versus others.
One versus all.
One versus others.
Yes.
Yeah. So if you do, for example, the green one
Yes.
versus the two. So the two here would be one class, right?
Yes.
Okay. So here, if we want to use the LDA, the projection will be on this line.
W2, 3, W2, the red one.
It will be almost like
The red one.
green versus others. You okay with me? Green versus the others. What will be the separations?
The red one. The red one.
Let me think. Okay. I said class. This is one class.
Yes.
And this is second class, right?
Yes.
So this we have to separate. This is separation. No,
Yeah.
No, this will be overlapping if I do like this.
no. I'm not talking about projection. I'm talking about separation. So separation and projection are perpendicular.
Okay.
Right, okay. Okay.
That makes
Okay.
sense.
So you have to agree. If we say separation, in the line. Projection, yes, I agree with you.
Doctor, I didn't get it. What do you mean by separation here? I thought we are doing these lines to project the data.
No, I'm talking about two things. Do we need to classify one versus one, or classify one versus others?
So when we say W13, what does it mean?
Okay, so W13, we are doing, this is a separation when we classify one versus three.
One versus
Three, yeah. So the red one, we remove it from the study. Only green versus blue. Okay?
So it's like there is no other class.
Yeah, exactly. Okay, or what we can do,
So doctor,
Yes.
which one is better?
it depends on the data set, honestly. It depends. It depends. Yeah. We cannot say. We cannot say. But if you do one by one, and if you do the separation, and all the region they have the entropy 0, means we are in the perfect range. So you can do it measured by the entropy.
So that separation, what is it called? That is LDA as well?
The separation.
Yeah, here, what is this? What is this?
Here you use LDA. LDA is more than enough.
But LDA is not a separation. It's like you have to have a line where when you project.
Yeah, no, okay. Okay, what is LDA? We have the data, we do the projection, yes or no?
Yes.
Okay, and the separation is this point, on this line.
Yeah.
So what does it mean? Any data in this region, when you do the projection, is it in the region 1 or in the region 2? So the projection line, the perpendicular to it is the separation.
Exactly. This is LDA.
Yes.
But here we are not doing this.
Yeah, we're doing, we can use LDA, it's fine. You can use LDA or regression. Both of them, they give line, what we call it, linear boundaries. Both of them. So you can use any one of them. Or you can use what? Gaussian distribution, and they have the same covariance matrix, and it will be the boundaries is aligned.
So doctor, we can do either the separation or projection first. Doesn't matter.
Sorry?
It doesn't matter if you do the separation first or the projection.
Yeah, but we're talking about LDA, right? But LDA, you have to find the projection.
But here, we didn't find the projection. We directly did.
Okay, let me give you an example here. Yeah, okay. Let's say I have this data here. Yes, and I have this data here, right? When I do the projection, is here, right? You okay with that? Yes? And this is the separation, right? So what will be here? Anything, this is class 1, for example here, or class cross, and this is class is circle. Take the data here. We do the projection, what will be here? And this one. So it will be, this is the separation. Anything here, when you do the projection, will be in the class of square. Anything here will be in the class here. So it's like we are separating to the line.
Yeah,
Okay? So the same way, you can do all projection and you do the decisions, but at the end, we are separating the region in two.
And this is
We
all.
call these two lines now. Because
Okay,
it's
this is the projection line, and this is the boundary line.
And this scenario only will be true then once we have the covariance, same covariance. What if we have different covariance?
Covariance?
Yeah.
No.
In this slide, we
If
have
we're talking
same
about
covariance.
LDA, there's no covariance.
Right.
It's just how to calculate, we can do covariance. But here, for example here, if I'm looking for, let me do it another way. Where they are. Okay. Just first what we did last time. Imagine I have data set like this, and I have data set like this. Okay, what do you think here? What is the covariance matrix here? Is it diagonal or not?
Which one?
This one.
No.
Why not? Okay, this one, is it diagonal or not?
Yes.
And the value of the diagonals are the same or not? Are the same, circle are the same. Here, if I do this one here, this one here, is it diagonal or not? Diagonal. Yeah. The value of the diagonal are the same or different? Different. So this is something like 0, 0. On x is small, on y is bigger. Here, it is not diagonal because it is oblique ellipse, right? So what do you think? What is the boundary line here? Is it a line or quadratic? It's quadratic because they don't have the same matrices. But if I do something like this, what is the boundary line is a line. Okay, by using Gaussian distribution. So we have the data here, we have the data here, we have to estimate the PDF, we get the Gaussian distribution, if they have the same covariance matrix, we get a line separation. As we proved it last time, you can
Doctor,
check.
but like this it was initially, then if we did not do the projection first, how can we do the separation line?
No, this is not projection.
No,
Here is projection. Yeah. So here, the line, you can use this, or you can use this one with the same covariance matrix. Both of them, they give you almost the same line. Almost the same line. I will give you examples in a few seconds, please. Look, I have two data here. I try to estimate the two PDF. Look here. What do you think here? Is it they have the same covariance matrix? No, because if you look here, the boundaries is quadratic. Okay, so this is the normal one. But here we have a problem here. Usually when the data is small, this is the PDF in high dimension. I have to estimate the covariance matrix. I have to estimate the mean in order to get the Gaussian distribution, right? We have the data, the blue one or the red one. You can estimate the covariance matrix. You can estimate the mean. At the end, I can estimate this shape. We call it bell shape, okay? The Gaussian distribution. Clear? Look here. Now we, yes?
Now, if you go back there, that equation, is it the Mahalanobis distance?
Exactly, but it is on the power, is Mahalanobis distance. Only on the power. Yes. But you see here, it is multiplied by, you see here, determinant here, right? So it depends, it is almost like Mahalanobis, but not. Okay, because we have the determinant is different from this one. But this we call it Gaussian distribution. Okay? So look here, if I do the cutting here, because in 2 dimensions something will be something like this, and the other one is something like this, right? So if the data comes here, it belongs to which class? Okay, so this one, right? This is class cross, this is class circle. If we are here, is it most likely to the cross? Here, circle. Here, how we can do? Which one is high probability? The cross or the circle? Exactly. So here is circle. So this is exactly the separation. This is the line separation. Anything is circle, anything here is cross. You see this one here? Make rotations. Make rotation, you will get the same shape here. Okay? Every time when you cut, you can do this. So what does it mean? I did the PDF, the probability density. I did the probability density. When we have any point, I will calculate the probability for the first one, the probability of the second one. The highest is my class. But here, I want to make now this one to make it easier for me to do the estimation of the covariance matrix. So what you do? I will assume that the variable, the M features are independent. Okay? So look at what we do. Those two here, do you think they have the same covariance for the shape? Yes. So the separation is a line. Now, look at what they do here. If they are independent, do you remember in the joint distribution functions? If they are independent, what does it mean here? The probability of x equals to x1 and y equals to y1. Here the probability, right? Here the intersections, it became always what? A product. So this what does mean? Independent, right? Okay? So here I have two features. If I have m features, it will be the product. Look for example here. The distributions of something, it will be the distribution on x-axis and on y-axis. Okay? Why we do this one here? Look to the equations. This is the PDF, Gaussian distributions. If we suppose they are independent, what does it mean? The covariance matrix is diagonal. Covariance matrix is diagonal. How to find the inverse is 1 over the variance. If you do this multiplication of Mahalanobis distance, it became like these summations, and the summation here, it became the product. As simple as that. So, if you want to find out if the variables are independent or not, we need to see if the covariance matrix is diagonal. It is not correct to say independent, but they say they are not correlated. Okay, to be more accurate. So look here, for example, from now, in order to estimate this cloud or the Gaussian distribution, I can estimate only on x-axis and only on y-axis. So, what will be the probability of x given I am in the class I? It will be x1, x2, until xm. M is number of features. They are all independent. So what we need to do? We need just to estimate the mean and the variance for each axis. And this is easy to do. Okay? It does not require to have a big data set. So this we do it because we don't have, if the training data set is big, just go to the Gaussian distribution. If the data is small, try to go to we call it naive Bayes classifier. Mean independent, that's all. Let me give example to make it easy for you. Okay, look here. I have a class I, yes? What will be the size of the class I? What is it here? From the slide. Sorry? I have the class, this is class WI, right? Yes? How many data we have here? NI. Clear? NI data inside, right? How to find the mean here, please? The mean. The mean of I is the sum of all xi divided by ni. But this is a vector, please, okay? I put this one to make a vector, or it is a column. Okay, how I can do it? I can do all the projection here, because they are independent, right? I can do it only the projection here, and I can find the mean here. The mean I on the axis 1, what is it, please? is the same sum, but I take only the first coordinate. Because what is xi here, please? This is two variable, right? xi1 and xi2. Like we take two features. Is it clear? The same one here. What will be here? Mu I on 2 is sum over ni. We take xi, but take the second coordinate. We have the mean. We have how to find the variance. You remember the variance, right? This is the mean. What will be here? The sum of xi1 minus the mean square divided by ni or n minus 1. Doesn't matter too much, okay? So I have the mean, I have the variance. So what will be at the end? My probability is this one. Same in one dimension, like as we did with the z distribution. If you remember, we have the variance minus the mean over this one, and this is just the normal distribution, the Gaussian distribution.
So here you have two means and two.
Of course, if you have n features,
How will you substitute it in this equation? Because you have two.
exactly. So what will be now the probability? For example, here. Let me do it here. In this slide here, I did 2, right? Yes? Okay. So what will be the probability of x1 giving I am in W here? What is the probability here, please? Is 1 out of 2 pi sigma 1 square, yes, exponential of x1 minus mu I1 square divided by 2 sigma 1 square, right? This is the probability. Clear? Okay. Now what I want to do, I want to say if I have any x, I have given x, I want to calculate is it belong to the class I. What is it here? By conditional, it will be probability of I times probability of x given wi. Do you agree with that one?
Yes.
As we did. What is this one here? It is exactly the product here. X, there is two features, right? So what will be here, please? Pwi, it will be the probability. The first one, it is 1 after 2 pi sigma 1 square exponential, what is it? x1 minus mu I1 square over 2 sigma 1 square times the same thing. 2 pi 2 square exponential x2 minus mu I2 square over 2 sigma 2 square. I'll give you an example just to have the same distribution. Every distribution Gaussian and Gaussian here. There is the mean on x, the variance on x. The mean on y, the variance on y. Both of them there is Gaussian distribution. Just we multiply them. So how to find if this x belongs to the class 1 or 2 or 3 or 4? We calculate this one for class 1, for class 2, for class 3. The maximum is most likely to be my class.
Doctor?
Yes.
If you have 10 features, then you have to multiply it 10 times?
10 times, yeah.
There's no short with that.
It is much better than doing in one shot. It's like Gaussian distribution. It's better to do antibandus. Yeah, one data is small, I'm saying. One data is small. Most likely, this is better in terms of accuracy, in terms of estimations, and so on. I'll give you an example to make it clear. Look here, please. This is example, right? Can you read here? We have two classes, plus and 0. Each class they have the same number. What does it mean? N1 and N2 are the same. Yes? We have two scenarios, A and B. Can you please draw a decision boundary that Gaussian naive Bayes classified? Okay, when I say naive, I mean they are independent. What does it mean independent? The covariance matrix is diagonal. Okay. What does it mean diagonal? Either we have circle, either we have ellipse vertical or horizontal. There's no oblique. So here, according to you, they have the same side, Let's take the circle one, or let's take the A, please. What is the boundaries here, please? Decision boundary. It will be the region of the red and the region of the blue. Okay, we can say it is diagonal, right? But do you think here, let's say about the covariance matrix of the red one, is it diagonal, right? Do you think the values on X and the values on Y are the same or not?
Which one?
The red one. Okay, look here please. I want to say,
Sir, I don't get the figure.
I'm coming. Let me do it here. I will draw it, try to do it nicely as much as I can. Okay, I have this one is here. Here I try to do it in this way. Okay. This is my the red one, and this is the blue one, right? Okay. My first question is here. Do you think the covariance matrix for the red one is it? I know it is diagonal, right? Is it like this, or like this, or a circle? What do you think? I can add question like this, right? The covariance matrix, which shape is it? Ellipse vertical, or ellipse horizontal, or circle? What do you think? You have to justify your answer, please. Let me say something. Here, 3, 3, 3, 3. So the distance here,
I think
3,
it's a circle.
9, 3, 9. Okay, I will add this number.
Circle.
Why this circle?
No,
Why
no,
this
ellipse,
Ellipse.
ellipse because the X and the X is
Oh, yeah.
the X
No,
and
no,
the
no,
Y
sorry,
are not the
sorry.
same.
No, no, sorry, 6.
Yeah,
Sorry,
X is a
6.
circle.
Yes, it is circle. Thank you. So here it is circle, right? So what should be the ellipse here, please? The circle here, it will be the. I try to do 9 as I can. Okay. The blue one. What do you think? Same. Do you okay with this one? Okay. Imagine now that the two things we have the same Gaussian, right? The same Gaussian. What is the boundaries line? They have the same covariance matrix, so the boundaries is a line. What should be the line that you can separate?
Like this. Diagonal.
Thank you. Exactly. Done. Here, sorry. Clear?
Yeah, but doctor, I didn't get how they conclude it is a circle or. I don't know.
Exactly. The distance here should be equal to this distance here. Because the variance on x-axis and the variance, we did it in the midterm, remember? When the oblique?
Yes.
Yeah,
I
yeah.
didn't solve that question.
How? Did I give the solution online or not yet? Really? So please just remind this in the email. I will post it online. It's very important. Yeah. Okay. I will give it to the solution later on. So we look to the values on x-axis and the values on y-axis. If they are the same, what does mean? It means we have 2, 2, 0, 0, or 4, 4, or 5. Clear? Okay. Let's go to the second one, please. Try to guess without help. So what is the boundary line here? Is it a line?
No.
Are you sure?
It's gonna be
The variants are diagonal, but
No. The boundary line. Guess. Is it a line or not?
The values are not same.
This is not. Yes, correct. It's a line. So what should be the boundary line? Which shape you think?
circle.
Circle. Good. So circle. Where do you have to put it?
It's gonna be closer to the smaller.
Okay. I give you a hint about something only. Look at. And they have the same side, right? The same side. Look at. This is. Sometimes I will do a cut and try to sketch. Look at. The values in this one is small, right? Yes?
Yes.
The area is
Smaller.
1. The area of APDF, probability density function, is 1. Take another one. The values is which one in values is bigger, please?
The blue one.
Sorry?
Blue one.
Okay, excellent. So I give this just hint. Tell me what is the boundary line.
think it's gonna be closer. It's gonna be big. It's gonna be like closer to the red one because the blue one will have more boundaries, I guess. No, I think it's gonna be a circle closer to the red.
Okay, do you think it is closer to the red one or closer to the blue one?
Closer to the red one.
Why?
No, it's closer to the blue one.
No, because the variance is higher, it's bigger in the blue one. No, but if the boundaries.
So I'm trying to.
We decide by boundaries, it's closer to the blue one.
It is circle, please. I'm just giving idea. Okay. So the boundaries is. Look to here. We are exactly the same scenario, right? Where is the cutting here? Is more close to the center? Yes or no?
Blue one, yes.
So it will be close to the red one. Is exactly here the boundaries line. Look here, take this one. Look here, I cut here. Look here. This we have big. Look, the red one is something like this. Okay? The blue one is really flat. Clear? Take the cut here, you will get exactly something like this. The red one is something like this. And the blue one is something. So you see the cutting is close to the. This is the boundaries, right?
Yes.
So it's close to the red one. Because look here, you have the area. Look here, the area is 1, right? If you make it the flat, it's going like this, right? So the intersection is immediately, almost immediately.
That it's close to the blue one, right?
The red one.
So because maybe if you make.
Look here. Look here. Do you understand this one here? Okay. Look here. This is my line here. Is here. And this the red one is something here. Or here, for example. Right? So this is really close to this one. Yes,
So is
image.
it because the variance is small, so anyways you shouldn't find points.
Exactly. Because look here, everything is located here. After dim, it directly goes to 0. Directly. The other one is really spread out. Okay, before doing this one, I will keep it for you. Do it at home. Let's do this one to understand. Okay.
But doctor, again, how can we I don't get it really, how can we transform this graph to this one?
Okay. Look here. This one. Look here. This one is Gaussian is like this, and the other one is like this. I'm looking for the top. It's giving this density. Now try to cut it like this. Cut here. Cut. This is exactly cut. When you cut here, you will see this one.
Because the more the data is spread, the more it will be.
Yeah. Yeah. Okay. Yes, because why? You can see it in different way. The variance is blue, right? Bigger. So what does it mean bigger? The gravity, it attracts you more, right? So what does it mean? If you are here, you will be attracted by the other one. Unless you are really close to the red one. You can see it in this way. Is it clear? Yes? Okay.
The same concept when you describe the bigger planet and smaller planet concept.
Yeah, of course. This is what I'm saying. The gravity, exactly. Yeah. Yeah. When you are here, the planet is big and you are small. You have to have high speed to do it. Well, why we call it a black hole? Because even the light, the electron, to come to your eyes to see it, you cannot. Because any electron or proton is coming to it, it's absorbed by high gravity. So we cannot see anything. Because the light, when there is reflection of the light on our, when it is black hole, everything is absorbed by it.
Professor,
Yes.
just to clarify.
There is 5 or 6 examples like this. Don't worry, there is a lot.
No, I mean because I'm just justifying why we did the circle closer to the.
Yes.
Because if we have a new point closer to the in the other area, we should have the attraction more in the blue one.
Yes, exactly. Exactly. Yeah. Anything there, it will to attract to it.
Yes.
Yes. Something has power, he take the length from the red one. Yes. To take it more if you want to see it in this direction. Look at it. Now we have to use base classifier. You have how many classes we have? A and B. How many features we have here? How many features? 1 is X. X is features, Y is output. What is the mean of A? Is 0 plus 2 divided by 2 is 1, right? The mean of B, 3 plus 4 plus 5 plus 6 plus 7 divided by how many? 5. You get it? 5. We calculate the variance for A, we calculate the variance of B. You don't have to do the variance and so on, right? What is the probability to have A? Class A. Is 2 out of 7. What is the probability to have B? 5 out of 7. Yes? Now, let's agree together. Alpha, I will call it is, alpha is probability of x equals 2, given that I am in the class A. Beta, I will call it, is the probability of x equals 2, given that I am in B. Okay?
But we have x equal 2, that will go to A, so why not?
No, I didn't ask any question. I'm just giving data. I'm giving assumption alpha and beta. Now we go to the questions. Let me just sketch x and y here. We have x and we have y. And here we have from 0 to 0, 2, 3, 4, 5, right? 4, 5, 6, 7. 0, 2 are A. And this is B, B. Okay, we call alpha is the probability of x equals 2, given y is A. And we call beta is probability of x equals 2, and y is B. Okay? Questions here? Do you think here there's typo or not? Sometimes I'm giving a wrong answer. You have to check. Do you think the probability of x equals 2 and y equals to A? Is it true, this one?
Yes.
So please you have to recognize this one here, please. Okay, the probability of A given B, what is it, please? Is probability of B times the probability of A over B, or probability of A times B given A, okay? So what do you think here? We are looking for the probability of x equals to 2 and y equals to A. But you have to use alpha and beta. Alpha and beta is giving A, right? So it will be here. The probability of x equals 2 times the probability of, here, A first, because the probability of y equals to A, and here x equals 2, probability of y equals to A. So this is by definition is alpha, right? I give it, right? And what is the probability of y equals to A? 2 out of 7, right? So is correct? Yes. So the first one is correct. Second one, the same idea. We get it here. Now, what is the probability of x equals 2? Why the third one? Why it is like this? Any idea?
The same thing.
This has nothing to do with the classification, right?
I'm coming to it. Of course, yeah. This is real classification. Because now I'm calculating it too. Look here. What is the probability of x equals 2? I'm coming in 2 seconds. You will get it. How to get this one here? Okay, look here, please. This is my sample space. This is, I do it y equals to A, and this is y equals to B, right? And probability of x equals 2, somewhere here, right? So what we can say, this one is the probability of x equals 2, and y is A plus, and y is B. Because they are disjoint event, we can add this. This will solve it in question 1, this will solve it in question 2. Yes? So you see how you can do it? This is important. Why it comes from here? Just any event, I can split it in 2 disjoint event. And then union is the total sample space.
Sir, the question is, what is the probability of x?
This one, calculate this one.
Yani,
Question 3.
For me, this is
I'm coming to it. Because later on, to do the classifications, we need to calculate the probability. Remember here, when we're doing about Gaussian distribution and so on. In order to say it belongs to 1 or 2, we have to calculate each probability.
Yeah, but
And then we choose them.
say that.
I'm coming. Okay? So is it clear here? Just, you see, your answer is here. It's coming. Probability of x equals 2 is done, right? Is it clear? Okay. Second one. Look here. What does mean this one here? Probability of y equals to a giving x is 2. What does it mean? What does it mean? Okay, I have two things. To say, okay, give me the features is 2, right? Can you please classify it based on the data set? Is it belongs to class A or belongs to class B? This is question. And you have the data here. We are using the conditional probability. Now, to answer these questions here, I have to calculate this one. Probability of y equals to A, giving x equals to 2. Versus what? Probability of y equals to B, giving x equals to 2. If this one is bigger, so it is class A. If this one is bigger, it's class A. Clear? So what does it mean here? At the end, if this one is bigger than half, it will be class A. If this one is less than half, it should be B. Because you have two classes only. So the separation is 50%. Clear? Or let me do another example. I'll come back to this one. I think it's here. Yeah, let's do this one. Okay. Here we do the distribution. You see this one here? I give you a data set, and I want you to find u equals to 0, mean the class 0, giving that 3 features. I give the features, the first one, the second one, and the third one. 0, 1, 0. Can you please tell me what is the probability here? I do the calculations, and if it's bigger than half, it will be 0. If it's less than half, it will be 1. So please, can you calculate this one? Just try. Tackle the problem and try to do it. But please, we have to use a, look at, naive one, okay? So what do you mean naive one? Take x and y and z, they are independent. Clear? Or do you want me to solve this one first one? No? Okay. Okay, let's do the first one, we do it together. But please help me in the 0, giving that 0, 1, 0. Clear? This one equals to what, please? The probability of u equals to 0, right? Over, because this is intersections, sorry, no. It's intersections, probability of u equals to 0, right? And this is probability of u equals to 0, x equals to 0, y equals to 1, z equals to 0, right? Equals.
It's not u equals 0.
Sorry?
It's not u equals 0. It's
Denominator is x equal to 0.
x equals 0.
Ah, yes. Yeah, thank you so much. Thank you. You're right.
Reinterpretation has been done.
Yes, you're right. Thank you. Good. Okay? So what will be here, please? Probability of x. So this one, it will be in the final exam. Please try to focus. Okay. So what will be here? Probability of x equals to 0, y equals to 1, z equals to 0. Given that u is 0, times the probability of u equals to 0. Okay. Now, what we said here, please? We said they are antidependent, right? Yes, how to use the antidependence here? Mean x and y and z, we can separate them as products. You see here? I am in the class 0, those are antidependent. So what will be here, please? The probability of x 0 given u is 0 times the probability of x equals to, no, y, sorry. Y equals to 1 given u is 0 times the probability of z equals to 0 given u is 0 times the probability of u equals to 0 divided by, I'm coming to it. First of all, is it clear?
Yeah, Doctor, the fact that they are independent from the question, or it is.
You see here, the questions here, we say, suppose that we have to predict u using naive Bayes classifier. When I say it's naive, means you have to use the antibanders and Gaussian distribution. Yeah.
It doesn't work for the
No, only for this one. Yeah, this is a technique. So please, can you tell me what is the value of this one from the table, please? This one. You are in u equals to 0. What is the probability of x equals to 0?
4 out of 1, 2, 3. 4 out of 8.
Sorry?
4 out of 8.
Look, if I say u equals to 0, what do we add? I am only at the three first cases.
2 over 3. 2.
What is x equals to 0? 2 out of 3. Thanks. Second one. Y equals to 1, given that u equals to 0. 1 out of 3. Next one. Z equals to 0. 1 out of. What is the probability of u equals to 0? 3 out of 7. Thank you. Done. Now, denominator, it is the probability of the probability of x equals to 0, y equals to 1, z equals to 0. To calculate this one, I always need to introduce the class. How to do it? I will just put u0 plus the same thing u equals to 1. You see, this one and this one, u0, u1, they are complement. I can remove them and we get our denominator. This one is exactly what we did in numerator, yes? The same way. You remember here? It was here, right? Remember here? At the beginning, it's the same thing. I can do it by conditional. I will get the same thing. So what will be here? 2 out of 3, 1 out of 3, 1 out of 3, 3 out of 7. This one, I will do it again by using the same idea. U1 conditional of this one. So what will be here, please? This one, I will do it here. The probability of u equals to 1 times the probability of x equals to 0 given u equals to 1 times u equals to 1, u is 1, probability of z equals to 0, u is 1. Okay, the first one, what is probability of u equals to 1? 4 out of 7, right? X equals to 0, u is 1. U is 1, 2 out of 4. Next one, please. 2 out of, is it sure?
2 out of 4.
3, 2 out of 4. And the last one, z equals to 0 is 3 out of
3 out of
4. If you do the calculation, you will get 8 out of 35. Conclusion. It belongs to which class? Is it U1 or U0? Thank you, U1. Because the value is less than half. It's small. For sure the other one. You got the idea? Next one. Do B, please.
So if it is half-half question,
It is small that is half-half. Take one randomly after.
say,
Yeah.
yeah.
Uh, But honestly, to have exactly half, when you have big, medium or big data set, is almost impossible. But in this small example, yes, maybe. I cannot give big data set, okay? But in case happen, take one randomly, or do another techniques, for example, another classifier. Hmm?
randomly is much easier.
Yeah, up to you. Up to you. Now we have another idea, they call it trust coefficients. When you do the classifications, we have to say how confident is the classifier. So you have to do some parameter. Anyway, we do the same thing, you get it half. For example here, if you do only one features, you get half. So here we have, you cannot, means you cannot do the decisions, you need more features. Same thing here, you can do the kind, you get the 0. But look here, please, here, look at the question now. I will not use naive, I use base classifier. What does it mean? I will suppose they are not independent. I will take them all together. Look what happened here. Take this one here, I will repeat again. Right? I will do it here. I will stop here. I cannot do the independence. I will do it as they are not independent variable. How to calculate this one here, please? How to calculate? Look here. What is the probability that you are in u equals to 0? What is combination 0, 1, 0? Look here. I am at 0. Do we have combination 0, 1, 0? No. Means it's 0. But it is not, you see here, it is not useful to use this one when the data is small.
Doctor,
But when data is small, when we do the naive, we are able to find some values. Yes?
can you please repeat?
Okay. What does it mean here? What is the probability of x equals to 0, 1, 0, 1, 0? When u equals to 0. Go to u. You have two values. Do we have combination 0, 1, 0?
No.
No. So 0 out of. But what is the probability here, for example? Is 1, 0, 0. 1 out of 2. You got it? Okay, there's a lot of questions here. They are almost similar. I will post it online. Try to do it. The same idea. The same. Okay. Before going to the prayer pause, just want to give you some ideas. I was planning to do it at the beginning, but I didn't have time to do it. Still have time? After we do a small exercise. Look, for example, here. You have 3 doors, yes? And there is expensive car or whatever you want, something you like, is behind only 1 door. You got the idea? I am presenting the show. You ask someone, you say, please pick one of the door. Yes? And there is a car behind only 1 door. And the 2 others, there is goat, animals, or something not important, right? You, for example, here, you select number 1 of the door. Yes. Clear? Now I will ask you, do you want to keep your choice or to... No, sorry. You choose this one, right? You choose this one here. What I do? I am doing the show. I know where is the car, right? In the 2 remaining doors, there is one, a car, maybe the car behind it, or maybe the car is the other, his choice. But at least the 2 remaining doors, 1 is empty. You okay with that? Those empty, I will open it. Maybe the both are empty, or maybe there's a car and empty. I will open the door. So now you have 2 choices. Do you have to keep your choice, or you change your opinion and you go to the remaining door? So which one is better strategy you want to do?
This is mind games, not.
But it is the decision here. For example, you have something, we call it reinforcement learning sometimes, or as you are doing, you are progressive learning something. You have some certain informations and you want to take decisions. So what does it mean here? You decide one of the door. I will open the one is empty. I will ask you, do you want to keep your choice or to go to the one still open?
I'll keep.
Which one is better?
It doesn't matter. It is still the same because the probability is half-half.
99% of the people that answered exactly your answer, this way you call it paradox. It is paradox. It seems it is same, but it is not at all. At all.
That's multi-hole problem.
Which one?
This is called multi-hole problem.
So which one you have to do? You have to switch. Because if you switch, I will not prove it, but just give an idea. If you switch, you will have 2 out of 3 to get the car. But if you keep your initial 1, is 1 out of 3. Look here, I give an idea. You have 3 doors, right?
Okay.
You choose one of them.
Okay.
What is the probability that you will win?
1 of 3.
What is the probability that the car in the two others doors? 2 out of 3. So when the guy opened the empty door, the 2 probability goes exactly to the one still closed. So it's better to change it.
But I have a question.
Yes.
Assuming the same theory, when I chose one, it was one of the 3, okay?
Yes.
And then you opened one.
Yes.
It's empty.
Yes.
Now the probability is half, 50-50.
No, at all. Because the other one, he was competing to the other one, he will open the door. So he knows it is
The one you select.
maybe.
Yeah, I know.
Another one is open.
I understand. But now, if someone else came in, not me, I already chose the third door, for example, and someone else to get to choose, it's 50-50. He will assume.
So this is what we call it paradox. But I will explain later. I'll give you 2 or 3 other ideas. Okay, look here from these numbers here. What can you
I know it.
detect here? You see here, when you try to learn something, even you do little by little, it's getting
based on
avalanche effect, right?
This is based on the experience you already got from the previous one. So if this gate was empty, then you have the higher probability that.
Exactly, yeah, I agree with you. Yeah. And here, what you can find out here, please. So when you are doing positively, you can increase, but it will need more time to get avalanche process. But when you are not doing nothing, you will be going back. When you are going back, the process of destroying is always significant than process of growing. The chaos theorem. You see here, dying process is more significant than growing process. So what does it mean? Learn every day a little bit. Here, I don't know why it doesn't work. So this question was asked with a lot of people. I think most of them, they didn't solve it. When you go to read calculus, they say the limit of x over x when x goes to 0 is 1, right? It's given to you. And when we ask questions like this, we go to the real life. X is angle, degree unit. Find the below limit. 99.99% of people, they answer 0. It's 1. As it's totally wrong. Who can tell me why? I'm studying something,
In plus 2 it is mentioned.
but when I do the apply, it's wrong. Why?
In plus 2 mathematics, it is mentioned.
I didn't hear you well.
Plus 2 mathematics, it is mentioned here.
Can you reformulate it? What is the wrong things here?
The wrong thing is it is not equal to 1, but they mentioned that it is equal to 1.
No, it is correct. Calculus theorem is correct.
Yeah.
It is correct. The wrong things here is the degree angle does not angle in degree does not exist in mathematics. Doesn't exist. It's only radian. When you do radian here, everything change. It will be the limit is pi out of 180. So what does it mean? When you read something, when you go to the reality, you have to do the projection in the nice way.
So doctor, in case if it is equal to 1, this is based on a degree.
Radian. Radian. Degree doesn't exist in mathematics. So here, when you put sine x in degree, you have to change it to radian. And here they are not the same. Another thing here. Can you please try to link all those dots without taking your hand out?
Yeah,
So I try to get quickly. There's a lot. Think out of the box. Most of the people, they stay inside the box and they will never do it. But if you do it outside the box, you cannot. But when you think outside, you can. You see here, you have to go outside and come back again. Here, this was, I think, interview in one of the company. Look here, please. Just to summarize it in brief way. Okay, look here, please. You was here, and you were facing a wild animal, right? You were scared. You went to the south with 50 kilometers, for example, right? You go to the east with 100 kilometers. You go back to the north with 50 kilometers. You will find yourself at the same position, facing the same animal. The question is, what is the color of the animal? Yes. First of all, what do you think? What I'm giving, it makes sense or not?
No.
Because why?
Color was not mentioned.
It makes sense. Honestly, it makes sense. Okay, so the questions, it is weird, but it is, if you understand the question, you can find the answers. Okay, mathematically, if you go from one point, going this one, you will not reach this point. If we are in 2D, in flat Earth, but we are living in the Earth, right? The only point, if you do this one, you come back to the same point only when you have in the
White.
north part. And it will be, you do south, east, north, you come back to the same point. And he is living the white bird. So you have to think outside, because if you think in 2D, you will never find a solution. What I want to say, when you're starting research, most of the people, they go to literature review. And this is really wrong. Why? You will be biased, you will think like them. You will be always following them. If you want to be odd, to create something novel, find the problem, try to think about it by yourself. Later on, go to literature review, and you can merge your idea with their idea. But this is really, really important.
Professor,
Yes.
what about the flat earthers? Then your assumption is completely wrong. The
No,
flat-
I'm talking,
flat-
you
flat-
are in Earth.
No, I'm saying if the flat earthers, then you
Yeah,
know.
it's not possible. Yeah.
It's not possible.
Not possible. But we are not living in the.
But
Oh, there's two theories. Something they said flat, something they said circular.
There's so many people believing that it's flat.
Yeah, I have a lot of people, even my friend, they believing in it. But for me, no, I don't think so. I don't think so.
But there's no proof for either ways.
I think I didn't take to the moon, otherwise I can't tell you, but not yet. You have to ask, yes. Ah, yeah, of course, yeah. We will do it, yeah, done. Think about this one, and we think about the prayer. Find the number of the parking place under the car, yellow.
78, 87.
87?
Why?
Because if we,
Yes, you have to turn it, it's 87. If you look it from this angle, it's difficult. Just change the position to look the problem, to solve it in better way. So if you change the angle, look at. I didn't solve it or no, I didn't solve it. Just turn your head, you'll find the answer. Okay? So what does it mean? What is the morality of this? When you are facing the problem, try to tackle it from different angles to solve it. Okay, let's see later on. Thanks.